Okay, so today I'm going to do the calculator active section of the final exam review. So I'm just going to jump right in. So a colony of insects has an initial population of 600. The number of insects triples every 4 weeks. So our initial equation is that this colony of insects has an initial population of 600. So, So this equation is going to be like A equals P times E to the RT. Or it can also be referred to as n equals n of 0 times e to the RT. Either way, this value is associated with that initial value. So for this one, I am going to do this a function of population, so I'm going to call it P of t, is equal to 600, that's the initial value, times e to the RT. So we don't know what the rate is yet. We are going to have to solve for that. So what it tells us is the number of insects triples every 4 weeks. So that means that if we plug in 4 for time, then our population is going to be 3 times the amount of 600. So it's going to be 1,800. Okay? And we're going to use that in order to solve for the rate. So we divide both sides by 600. And we are going to solve for the rate by hand, because when we plug it back in, that's going to be important. So we should get here, and then in order to get rid of the e, we natural log both sides. So on the left side, that'll stay as ln 3, and on the right side, the natural log and the e will cancel, leaving us with just 4r. So then we would divide both sides by 4, so we would get that our rate is equal to the natural log of 3 over 4. So then we can go back and we can write our equation. So population in relation to time is going to equal, again, that initial value times e. And now we know our rate, the natural log of 3 over 4 times time. Okay, so how many insects will there be in 7 weeks? So we're looking for P of 7. So we would just plug in 7 for time. So this one you can do it by just plugging it in, or you can do it graphically. I'll kind of show you both. So if you do want to plug it in, it would look like this when you plugged it in, and that's what you would get out. But I'm also going to show it to you graphically. I'm going to menu actions. I'm going to delete all, just so that we can do this together. Zoom standard. So I would hit tab, and I would type in 600, and then the E button is here, E. And then I would hit Control E to get the natural log. So the natural log of 3 divided by 4. And then we're doing times, because our calculator is dumb, it's going to be times x. Mine is in caps locks. Yours doesn't need to be. I honestly don't really know how to get it out of it. Oh.
Good morning. Everyone, please stand for the pledge.
Okay, I figured out how to do caps locks in that break. So if you are stuck in caps lock, you can hit Control and then Shift, and it'll take you in and out of that caps lock. So I'm going to go out of it, but it really doesn't matter whether you do a capital X or a lowercase x, it should still graph it the same. And so when we graph it, it really gives us nothing. And that's totally fine, because our initial population is 600, which would be on the y-axis. And we're nowhere near 600. So I'm going to hit menu, and then I'm going to go to Windows/Zoom, and I'm going to change my window settings. So I know that my Y max needs to be at least 600, just to even see the initial value, but I'm going to be a little more aggressive with it. I'm going to make it 3,000. So that I can get a little bit better shape of my graph. So if we want to find this value graphically, we would hit menu and then trace. And then we're going to hit graph trace. And then we can just type in the value we want to find. So I'm going to type 7 and hit enter. And so it should give you that same value that we were looking for otherwise. So that means that after 7 weeks, we're going to have 4,103. Normally we round to 3 decimal places, but we can't have a portion of an insect. So we do need to think about that in terms of the problem. Okay, so going to the next piece, it says, when will the number of insects be 1,200? So in this situation, we are plugging in 1,200 for that output, and we want to find, in this case, time. So this would be our setup, and then on our graph, we would have to graph this, and we've already graphed this, and then we'll find the intersection. So we'll hit tab and we'll plug in 1200. And it changed my zoom when I did that trace, so I am going to go back and change my zoom. So I'm going to change my Y-min. I'm just going to change it back to 0 so I can see that intersection. So then we'd hit Menu, Analyze Graph, and Intersection. And then we'll click to the left, and we'll click to the right, and it should give us this value here. The X value is what we're looking for here because we're looking for that time. So it would happen in 2.524 weeks. And we can have a portion of time, so it's okay. Just make sure you're including your units there. Okay, moving on. So the next one says, in a bacterial culture, the number of bacteria B is modeled by this equation, where T represents the number of hours since noon. How many bacteria will be present at 5 p.m.? So the number of hours since noon, that's important so that we can accurately put in time. So in this situation, time would be 5. But just be careful because if it had said the number of hours since 1, time would be 4. So it's not necessarily always this number. So please be careful there. So again, I'm going to go ahead and just graph this. So I'm going to hit Menu, Actions, and I'm going to delete all. And then I'm going to go ahead and graph this equation. Again, you can just plug in time, but I'm going to graph it because I'm going to have to graph it anyway for the second piece. So I'll hit Tab, and then I'll put 15,000 E. Again, I'm clicking E down here to the 0.27, and my calculator's dumb, so I'm going to put X. And then I'd hit Enter. So again, I'm only seeing a portion of it. That's because, again, our starting value is 15,000. So we're going to really have to see more than that. So I'm going to go, again, to Menu, Window/Zoom, Window Settings, and I'm going to change that Y max to 30,000 so that I get a little bit better picture of my graph, because, again, I know that I'm going to need at least 15,000. So how many bacteria will be present at 5 p.m.? So that means we're looking for B of 5. So this would be the setup. We'd plug in 5 for time. And in our calculator, again, you can plug that into the calculate portion, or we can hit Menu, Trace, Graph Trace, and then just type in the number 5. Okay, and it should give us, again, we can't really have a portion of bacteria, so 5,700 or 57,861 bacteria. Again, that's coming, it's hard to see, from this graph right here. Okay. And again, it did change my window again, just because this number wasn't in the window that I previously had. So when that happens, just go back and you can kind of change your window settings again. I'm going to change that Y-min back to 0 so that I get a little bit better picture. So now it says, when will there be 22,000 bacteria? So again, we would set this equal to 22,000. And we want to find the time here. So we already have our equation graph, which is great. So we just need to graph this other equation. So again, we'd hit Tab. We'd type in 22,000. And we should hopefully see that intersection in our window. We'd hit Menu, Analyze Graph, Intersection, click to the left, click to the right, and we should get it here. Again, T is the number of hours since noon, so T would be 1.418 hours. And so that could be our answer, or it could be asking like the actual specific time, which in that case it would be, well, actually no, I'm just going to leave it like that. Okay. Yeah, I'm just going to leave it like that. Okay, moving on to the next one. It says, calculate the balance after 7 years if you invest 15,000 at a rate of 9% compounded continuously. So that compounded continuously means we're going to use the continuous compounding equation, which is A equals P times E to the RT, where P is our initial value, R is our rate, and T is our time. So for this one, if our initial value is 15,000, our equation would be A equals, 1,500. 1,500 times E. It told us that we're at 9%. We want to write that as a decimal, so it's going to be 0.09. So 0.09 T. And we can also do A as a function of T. Actually. Right out. I did that too close to it. Okay. And we're looking after 7 years, so what that means is we're looking for A of 7. Okay, and again, you could graph this, but in this situation, I don't need this graph for additional parts. So here it may actually be easier to go ahead and do it in the calculate portion, in which case we would do 1,500. Again, we're going to hit that E button, and we're going to do 0.09 times 7. And so we're talking about money here, so we only want to round to 2 decimal places because we're talking about money. But the money should be $2,816.42, because we're rounding, cents. Okay, the half-life of a certain radioactive substance is 16 hours. There are 60 grams initially present. When will there be 3 grams remaining? So the equation for half-life is N equals the initial value times 1/2. And then it's the time, but it's over the length of a half-life. Okay, so in this situation, I'm going to do it as T. Our initial value is 60 grams. We're doing this to the 1/2. And then we're raising it to the time over the length of a half-life, which in this case is 16 hours. So that would be our setup. And we're looking for when 3 grams are remaining. So that means we want to set this equal to 3 because we're looking for the time. So we would say 3 equals 60 times 1/2 to the T over 16. So this one we are going to go ahead and graph. So again, I'm going to hit menu actions and I'm going to delete all. I'm going to leave my window. I may change it in a minute, but I'm just going to leave it for now. So I'll hit tab and I'll type in this equation, so 60. And then we want to probably put parentheses around that piece, 1/2. And then we're doing a little caret because we're raising it to the x divided by 16. Okay, and again, this is why we maybe want to change our window. So I'm going to go menu, window/zoom, window settings. We're real high up right now. If 60 values are initially present and it's going to be decreasing, we really only need to see 60, but I'm going to see 65 just in case. Okay, so that's a little bit better, but maybe not great. We maybe want to change the x values. So window/zoom, window settings, I'm going to change the x max to say 50 so that I get a little bit better shape of my graph. And so then I'm going to go ahead and I'm going to graph 3. And I still can't see the intersection there, so I actually need to even go further in my x values for those window settings. So maybe I go to, I don't know, 300, just to be safe. Yep, now I can definitely see that intersection. So then we'll hit menu, analyze graph, intersection, click to the left, click to the right. And so that is happening at 69.15. I'm going to round it to 1 hours. So please make sure you're careful with units. If our original half-life is in hours, our answer needs to be in hours as well. Okay, the recommended percent P of oxygen by volume in the air that a diver breathes is given by this equation, where D is the depth in feet of the diver. At what depth is air containing 10% oxygen? So what this is saying is we're plugging in 10 for the percentage. So we'd say 10 equals 660 over D plus 33. Now, you could honestly solve this by hand. You'd multiply by D plus 33 and then solve for D. I personally think that that would be easier, but it's totally up to you guys. So if instead you do want to use a calculator, again, menu, actions, and delete all. So we'd plug in, one of our equations is going to be 10. And then we'd hit tab, and we'd have to plug in the other one. So we'd do 660 divided by, you are going to have to put parentheses around that denominator. And again, we're going to call it x plus 33. So we should hopefully see that intersection. We'll hit menu, analyze graph, and we'll do intersection. So we'll click to the left, click to the right. It's happening at 33. So 33 feet. Okay, so now we're working with a triangle and we want to find the value of x. So in relation to this angle of 32, we have the adjacent and the hypotenuse. So because of SOHCAHTOA, we're going to be using cosine. So we'd say cosine of 32 is equal to the adjacent, which is 9, over the hypotenuse, which is x. So now we want to solve for x. So we'd multiply both sides by x. And then we divide both sides by the cosine of 32. So we would get that x is equal to 9 over the cosine of 32. And that is what we would plug into our calculator. So this one, you do want to do this in the calculate portion. So you do 9 divided by, and then you're going to hit the trig button. You're going to click over to cosine, and you're going to do the cosine of 32. Again, make sure you're in degrees. If you're not, you can just go up there and you can click that, and it'll change it. So if you're in radians, you want to flip over to degrees. So we're getting that x equals 10.613 because we're rounding. And it didn't give us units, so we can just leave it like that. Okay, a 20-foot ladder is leaning against the side of a house that reaches 16 feet up the side of the house. What angle does the ladder make with the ground? So this is going to be our house, and we have a ladder that's leaning up against it. Your drawing does not have to be this detailed. It could be more detailed. It could literally be a triangle. It doesn't matter. So the ladder is 20 feet, so that means that this value is 20. And it reaches 16 feet up the side of the house. That means this is going to be 16 feet. And it wants us to find the angle that the ladder makes with the ground. So it wants us to find this angle right here. So if we're looking for that angle, which I'm just going to call, I don't know, A. If we're looking for that angle, that means we have the opposite and the hypotenuse. So that means we are going to use sine because of SOHCAHTOA. So sine of A is equal to the opposite over the hypotenuse. So to find the measure of angle A, we have to use inverse trig. So the measure of angle A is equal to the inverse sine of 16 over 20. So again, we'd hop on over to our calculator. This time we'd hit trig, but we're going to go to the inverse sine this time, and we're going to do 16 divided by 20. And so we would get that the measure of angle A is equal to 53.130 degrees because of that output. Okay. A man flies a kite and he is 25 feet horizontally from the kite. The angle of elevation to the string is 52 degrees. How long is the kite string? So we have a little man. He's standing here. His kite's in the air. Okay? And so it tells us that he's 25 feet horizontally. So that means horizontally, he is 25 feet away. Okay? The angle of elevation to the string is 52 degrees. So that means this angle right here is 52 degrees. And it wants us to find how long the kite string is. So we're looking here. So we do have a triangle happening here. And so in relation to this 52, we have the adjacent and the hypotenuse. So we're going to be using cosine. So the cosine of 52 is equal to the adjacent over the hypotenuse. So we'd multiply both sides by x. And then divide both sides by the cosine of 52. So we'd get that x equals 25 over the cosine of 52, and that is what we would plug into our calculator. So we'd go back here, we'd hit 25 divided by trig, click over to cosine, and we'll plug in 52. We'll hit enter. So that's giving us that the height of the kite is 40.60, again rounding, 7 feet, I believe. Yeah, feet long. So, solving the triangle, when something says to solve the triangle, that means it wants you to find all of the sides and all of the angles. So we're given some information here, but we need to find the rest. So the easiest thing to find first is going to be the measure of angle A. The way that we do that is we're going to do 90 minus the measure of angle B. So 90 minus 50. So we're going to get that the measure of angle A is 40 degrees. And while that's great, we don't want to actually use that moving forward, because if we mess that up, it's going to mess things up in the future. So the next thing we want to find is probably A. So we want to use this 50. So in relation to 50, we have the opposite and the adjacent. So we're going to be using tangent for that. So we'd say tangent of 50 is equal to the opposite over the adjacent. So again, we would multiply by A here. And then divide by the tangent of 50. So we would get that A is equal to 12 over the tangent of 50, and that is what we'd plug into our calculator. So we'd say 12 divided by, again, trig tangent 50. So that should be 10.069. Again, it doesn't give us units, so we could just leave it like that. So now we want to find C. And so we don't want to use A, though, to find C, because we found A, and so if we mess that up, we don't want it to mess up something in the future. So in relation to that 50-degree angle, we have the opposite and the hypotenuse. So in which case, we want to be using sine. So we'd say the sine of 50 is equal to the opposite, which is 12, over the hypotenuse, which is C. So similarly to solving for this one, we'd multiply both sides by C, and then divide both sides by the sine of 50. So we'd get that C equals 12 over the sine of 50, and that is what we would plug into our calculator. So we'd say 12 divided by trig sine 50. And so we'd get that that length is 15.665, and that should be the longest length out of the three that we have because it is the hypotenuse. So that is kind of a nice little way to check yourself. Okay, moving on to matrices. So when we're working with matrices, especially when we're doing this, we want to go ahead and store our matrices. So the way that we do that is we hit menu, and then we go down to matrix and vector, and then we're going to hit create and a matrix. And so these are talking about the rows, and then these are the columns. So we want 3 rows and 2 columns. And it should pop up, so if you don't put that in right, you can always fix it. So I'm going to plug in A, so we'll say 1, -1, 0, -3, 2, and 5. And then to store it, I hit Control and then this var button. It'll do that. And I'm going to set it for A. So I just typed in A in the down here. So that stores it. And then I'm going to do the same thing for B. So matrix, create, matrix. Again, I'm doing a 3 by 2. So I'll plug in -2, 1, 5 and 4, 0, and -7. I do kind of like to check back to make sure that I've plugged these in correctly, because if you mess up the plug-in, then the rest of your answer is going to be messed up. So then again, I'll hit Control Store, and I'll just click the B button down here in order to do that. So now it says find 7A plus 6B, so now I can just type in 7A plus 6B. So it'll look like, the glare is messing me up. Look like that. I'll hit enter. That'll be my answer. So my answer is -5, -1, 30, 3, 35, -28. Okay. So the next one says solve the system. So in order to solve the system, we need to go ahead and write this out as matrices. So the way we do that is we're going to write these values. So we'd say 1.5, -0.5, 1.5, and 1.5. We're multiplying those times x, y. And then those are equal to the matrix that is the answers to the equation. So this would be our setup. we're going to plug this in for A, and we're going to plug this in for B, and so then to solve for A and B, we're going to do A, or to solve for X and Y, we do A inverse of B. So, again, I'm going to hit Menu, Matrix, Create Matrix. This time I'm creating a 2 by 2. And so I'm going to type in 1.5, negative 0.5, and then both of these are 1.5. And again, I'm going to control store that as A. And then I'm going to hit Menu, again, Matrix, Create Matrix. This time I'm doing just the answer matrix. So that one I need 2 rows, and I need just 1 column. And so that's negative 3.5 and negative 7.5. And I'm, 7.5, and I'm going to store that as B. Okay, and again, I do like to check my matrices before I go ahead and type it in. So now I'm going to type in, this is driving me crazy. So I'm going to type in A, and then I'm going to the negative first, and then I kind of click over, and I'm doing times B to get my answer. And so this would be the answer, but we want to write that as a coordinate point. So the answer is actually going to be negative 3, comma, negative 2. So your X value is negative 3, and your Y value is negative 2. We can do the same thing for a larger matrix. So again, we'd set it up the same way. So I'm going to make my first column X's, my second Y's, and my third Z's. So it'd be 4, 2, negative 1, 2, 3, negative 2, negative 4, 4, 2. This time, this is going to be X, Y, Z from that variable matrix. And then it's equal to 6, 5, 0. Okay. Oh, you can't see that. Okay. Okay, so again, I'm going to do the same thing. I'm going to plug this in for A, plug this in for B, and do A inverse B. So again, I'm going to hit Menu, Matrix, Create Matrix. This time I want a 3 by 3. So sometimes when you click down, your calculator is going to do that. If it keeps doing that, you can hit Tab, and it'll take you to the next one. So 3 by 3, and I'm going to plug in this matrix. So 4, 2, negative 1, negative 2, 3, 2, negative 4, 4, 2. Okay, and then we're going to hit Control Store, and again, I'm going to store that as A. So again, matrix, create matrix. This time I want a 3 by 1. So 6, 5, 0. And again, I'm going to Control Store B. So then again, I can type in A to the negative first times B to get my answer. So this would be my answer, and again, we want to write that as a coordinate point. So the coordinate point would be 1, 1, 0. So this means X is 1, Y is 1, Z is 0. Okay, next one, find the product. So again, what we can do is you can either just type this in as is, or you can assign this to A and this to B, and then multiply it that way. That's what I'm going to do. So again, Menu, Matrix, Create Matrix. I'm doing a 2 by 2, so negative 7, 6, 6, and 1. Control Store as A. And then Menu, Matrix, Create Matrix, another 2 by 2, negative 4, 1, 3, and another negative 4 there. And then Control Store that as B. And then I can just type in A times B. And it should give me my answer. And so my answer is going to be 4, 11, negative 28, and 19. Okay. So this last one you don't really need a calculator for it. So we're trying to solve for X and Y with the matrix equation. And so X and Y are kind of mixed in sporadically throughout here. So you just kind of want to find the one that's going to work best for you. So I see that I have an X here, so that is in the middle of the bottom row. So I want to make sure I'm pulling all the values from that middle bottom row as I type this in. So I'm doing 2 plus X equals 6X minus 3x. And so that would be my equation set up, and so now I just want to solve it. So this would be 3x, so you'd subtract x, and then divide both sides by 2. So we'd get that x is equal to 1. Okay. And then to solve for y, again, we're going to look for those y values. So we should hopefully see we have a y here, but it's an x and a y. So if I messed up x, I don't want to also mess up y. So I'm actually going to use the upper right-hand value because that's just a regular y on its own. So I'm going to use the upper right-hand value of all these matrices. So I'd say y plus 2 equals -1 minus 1, minus -1, right? Minus -1. So that double negative is actually going to go positive. And so we'd get y plus 2 equals 0. So then we'd subtract 2 from both sides, and we would get that y equals -2. And so that would be our x and our y values. And that finishes out the calculator portion. Okay. Hopefully everything's done. Y'all have a great day.